All right, everyone. In section 2 here, we're going to talk about the area of trapezoids, rhombuses, and kites. So how do you find the area of a trapezoid, a rhombus, and a kite? First, we have to talk about what the height of a trapezoid is. And like we talked about in section 1, the height is always the perpendicular distance between things. So the height of a trapezoid is the perpendicular distance between the bases. So the area of a trapezoid is 1/2 times the height times the sum of the bases, so base 1 plus base 2. So we look at example 1. It says, to prevent beavers from damming a drainage pipe, the trapezoid-shaped fence shown here is placed at the pipe. Approximate the area enclosed by the fence. So what we need for the area of a trapezoid, it's 1/2 times the height times base 1 plus base 2. So we need to know what is the height, what is base 1, what is base 2. So the height in this one is 8 square root 2. And base 1 and base 2 are 16 and 8. So the area is 1/2 times 8 square root 2 times 16 plus 8. And we end up with half of 8 is 4. So it's 4 square root of 2 times 24. All right. If we want the exact answer, it'd be 24 times 4, which is 96. So it'd be 96 square root of 2. And then we would do 96 times the square root of 2, which is 135.76 feet squared. So the average, or the area of this is 135.76 feet squared. 1/2 times the height times base 1 plus base 2. The area of a rhombus is 1/2 times diagonal 1 times diagonal 2. And is actually the same for a kite. The kite is 1/2 times diagonal 1 times diagonal 2. So if you look at example 2, find the area of the rhombus. So to find the area of a rhombus, which is 1/2 diagonal 1 times diagonal 2, we first have to find out what is the diagonal. So diagonal 1 is the distance. We'll do the vertical distance. So these diagonals cut each other in half because this is a parallelogram and they bisect each other. So that means each part is 8. So diagonal 1 is 16. Same thing for the horizontal diagonal. It gets cut in half, so each of these is 11. So that diagonal is 22. So the area of this rhombus is 1/2 times 16 times 11. Sorry, 22, not 11. I messed that up. I apologize. That should be 22. 1/2 times 16 times 22. And when you multiply this out, 1/2 times 16 times 22 is 176, and it's going to be centimeters squared. 1/2 times diagonal 1 times diagonal 2. As I slide down, checkpoint, find the area of each polygon. So number 1 is a trapezoid, and the area of a trapezoid is 1/2 times the height times base 1 plus base 2. So the height is 4, base 1 is 7, and base 2 is 9. So the area is going to be 1/2 times 4 times 7 plus 9. So 1/2 times 4 times 16. And 1/2 times 4 times 16 ends up being 32 feet squared. Okay, then find the area of the rhombus in number 2. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. So first we got to find the diagonals. Diagonal 1 half of that diagonal is 12, so the whole diagonal is going to be 24. And the second diagonal, since half of that is 18, the whole diagonal is going to be 36. Because each of these is 18, and each of the vertical ones is 12. So we end up with area 1/2 times 24 times 36. So 1/2 times 24 times 36 is 432 meters squared. All right, example 3. It says one diagonal of a kite is 2 times longer than the other diagonal, and the area of the kite is 56.25 square inches. What are the lengths of the diagonals? So let's start with our equation. Area is 1/2 diagonal 1 times diagonal 2. So if we don't know the diagonals, let's call one of them x. Okay, what we do know is one diagonal is 2 times longer than the other. So if one of them is x, the other one is going to be 2 times x. And we know the area is 56.25. So if we substitute in 56.25 equals 1/2 times x times 2x. So we end up with 56.25 equals 1/2 times 2 is 1, and x times x is x squared. So what we have to do here is take the square root of x squared. The square root of x squared is x, and the square root of 56.25 is 7.5. So diagonal 1 is 7.5. Diagonal 2 is 2 times 7.5, which is 15. And by the way, these are in inches. So 15 inches and 7.5 inches. All right, we are going to skip example 4. Actually, we'll skip checkpoint 4. Let's talk about example 4. So if you have the diagram in the backyard that looks like this, we're just trying to find the area. So we have 2 bases. The area of the top base is 3. And the length of the bottom base is 1, 2, 3, 4, 5, 6, 7. So you can count that up. And the height is 1, 2, 3, 4, 5. So to find the area of a trapezoid, it's 1/2 times the height times base 1 plus base 2. So it's 1/2 times 5 times 3 plus 7. So we end up with 1/2 times 5 times 10. 1/2 times 5 times 10 is 25 units squared. Okay, and we're going to skip the last one with the graph, and we'll leave it at that.